Hello, everyone. Welcome to Learning Activity 10 for CYBR601. We're going to be diving into the lab for discrete event simulation. So let's go ahead and go and get Anaconda loaded up. You know how to, at this point, you should be pretty familiar with how to get it loaded up. Here is Anaconda Navigator, and you'll want to launch Spider. And so once you get Spider launched up, you're going to be presented with this screen, right? Oops, no, that's not it. Dismiss, and we'll get over there, and then depending on where you last, I'm gonna close that out. There we go. Depending on where you last left, off on your Spider, it may have code pulled up from your prior Spider session. So, but I've got mine blanked out, so it's fresh. So I'm going to go and open that Learning Activity 10 lab for discrete event sim for car wash, this one here. So I'm going to load this one up. And again, remember, this is, you'll want to navigate over to files. In files, you'll get to lab materials, and then under lab materials, you'll have discrete event simulation here for lab 10. That's the file. Download that. You can come over here, hit download, and then get a copy of it local. And then in my case, I've got it in my CYBR601 folder here, so I'm going to go ahead and hit open. And then this is the car wash. This is the DES event simulator, discrete event simulation for the car wash, as it were. This actually is a SimPy example, but I've played around with it. I've adjusted it. I wanted to make it a little bit more explanatory in certain areas, but then also I made some adjustments to some other areas. So anyway, this is what we're going to be working with. And first things I want you to do is there's one thing we have to check on. And for SimPy, you have to actually install it, and that stands for Simulation Python, or Python Simulation. You want to install the SimPy Python library. And to do that, you'll want to come over to Anaconda Navigator. And what you'll do is go to Environments and go to the base root and then Open Terminal. And you'll be given this. And what you'll do is you'll do pip install SimPy, like that. I already installed it. It's a really straightforward installation. It doesn't take very long. Make sure you have, of course, if you got a good connection to the internet, it's gonna install real quick. Mine's already installed, so it's all good. I'm gonna exit out, and that'll be it. Once you've done that, you're in good shape. You can navigate back to Spider. Okay, once you've done that, one thing I want you to do is I want you to take these wash machines and I want you to back it off. I want you to make it 2 wash machines. I've got some explanation here where this is the time it takes to wash a car. You don't want that to exceed 8 minutes. So that's why I had it at 8, but I want you to back it off to 2 for the purposes of this simulation. Your random seed, you can leave that at 1, 2, 3. That's fine. Okay, but remember all the different components as it relates to discrete event simulation. You've got system state variables here that are being instantiated ahead of time. This simulation time, remember that system clock that we were talking about? That's here. I have that set to 60 minutes, but we could do 10 minutes. We could do 20 minutes. We could do 120 minutes, right? There's just different ways and different things we can do here. It actually gives you a lot of flexibility to do a lot of different things. So let's walk through the code so that you understand the idea between the modeled entities here. In this case, I'm using what's called an object, an object-oriented programming method, and we have a class, which is a class of car wash, and I make that known as a C underscore. So C underscore car wash. It's kind of old school, but that's the way I program to a large extent. So C underscore car wash. And then car wash has what's called an object wash in it. So remember, this def is a function, but we've got a wash object within the class car wash. We also have this init. That's an initial. That's a constructor. What we call a constructor that initializes the variables for the class. And that we don't need to get into the programming. Just know that that's what that is. And as we go down, there's another object called separate from the car wash that's independent, a separate entity. So we have cars. So I have an object cars that is going to be interacting. If we look here, if I select cars right here, I have an object car that interacts with the class car wash through the object wash. So car wash. So cars get passed over to the wash object within the class car wash. Okay, and let's see. And as we move down, I'm not gonna go through all of the individual specifics. This again is just a follow along lab. So just download this and make the minor adjustments, and we're gonna run this here in just a second. But here's the object setup. So this is this creates the initial state. So a number of initial cars and keeps creating cars. So this is the initial system state setup for the discrete event simulation. So as the car wash gets spun up online, it's not just how many cars can I get through. What this does is it says for each iteration through the simulation, another set of cars comes in. So what I want to know in the simulation is, what can the system handle, and where is the optimal queuing structure for what it is that we're trying to so in other words, if I have a set number of cars that are coming through, I'm sorry, not a set number of cars, but a set number of car wash machines, how many cars can I handle, given a couple different parameters, right? And in this case, how quick the machines operate, and what kind of load can this mechanism handle that I've created. And this is a perfect example. This queuing structure is a perfect example for a discrete event simulation. Okay, so there's some other things. I've got some notes here. This is a string literal, just some comment code here if you're interested in learning more about SymPy. Here's a link to that. And if you're interested in learning more about this particular video and simulating, there's a YouTube video here that you can go watch that's separate from this video and not related to what we're talking about here. Okay, the rest of this is just administrivia to get the to actually execute the Python objects, the class and the objects, and to get the whole simulation kicked off. So I'm going to go ahead and push play. I'm going to make sure I got random seed set to 1, 2, 3. Number of machines is set to 2. Wash time is set to 2. In other words, I have 2 machines that are running concurrently with a wash time of 2 minutes per machine. And then I have a car. So I have, in this case, it's car every 2 minutes. So create a car every 2 minutes. So that's the time interval. And then I'm going to have the simulation run over 60 minutes. So let's push play and see what happens. Okay, that's it. Done. So just like that, we just simulated 60 minutes. And so it did pretty... with two machines and a wash time of 2 minutes per machine and 2 cars... over 60 minutes, I've got a car arrive. So I start off with 0. And the way that you interpret this is a fun. It takes a little bit to get through. So what happens is cars, you got to pay attention to the arrival, enter, and then leaves. So I have 5 cars that came in, and then so 1, 2, 3, 4, 5 at 0. So we start off, we get 4 arrivals, but we only have 2 bays. Remember, we only have 2 machines, which means 0 and 1 um, are used, and then 5 is waiting. Right. Well, actually, it means that 2, 3 are waiting, 2, 3, 4 are waiting, and 5 arrives. So that means I get to, so I'm kind of already behind, right? And then as I move through this, car wash remove 22% of dirt for cars 0 and 1, and then that means that 0 and 1 are going to be leaving. So then that kicks off next. So I get another car arrived, and then 0 and 1 leave, and then 7 arrives, and then 2 and 3 now enters, and then enters the 2 machines that we have. So I'm already, after a couple minutes, I'm already out of control, right? This is just, it's problematic in terms of how this is, and you just keep following this through, and then you can start to see what ends up happening is I add in a lot of, let's see, as we go through, in an hour, car wash, so 34, let's see, 34 leaves and 36 enter. So what's interesting is, even though with this particular simulation, if I have a wash time of 2 minutes, I can pretty much level out and get people in and out of the car wash pretty quickly. So because you can see here, I know that because I have 34, 35 um, in an hour, they get washed, and then 36 enters the car wash, which means that I'm pretty much doing okay. It kind of gets out of control at first, but the system actually starts to pick up. If I can get my time, that's assuming that my wash time, it takes 2 minutes to get a car in and out. That's probably not as reasonable. So you're probably asking yourself, well, there's a trade-off, right? The cars that are getting washed 2 minutes, how reasonable is the car getting washed? Well, you can see here most of the time it's in the 20s, in the teens, in the 20s. On average, the car it's not getting a very thorough wash. So that's another part of this simulation. I actually had to make an adjustment so that took the the car wash percentage out of the box. If you go to pull down the code from SimPy, it's a pure randomizer from 50 to 99% in terms of the car getting washed. It had no bearing on time. I actually made an adjustment to weight the randomizer towards the wash time. So if we added more wash, then the car would get a little bit more dirt would get washed if as the time increases. So I actually weighted that in the program, in the code. So that was some things that I adjusted here. So let's as you go through this, you're probably asking yourself, well, what if we increase the wash time? Let's do that. Let's increase the wash time. Let's just go to 4 minutes, and then see what happens to our dirt removed, and what happens to our simulation. So there's a couple things here that I noticed right off the bat. So I reran the simulation, and so same thing happens. I get a queue from the beginning. I get these cars to enter in, and then I get 2 bays. I haven't increased the number of machines, right? So that stays the same. The only thing I changed was the wash time. So the wash time does have an impact on the cars get a little bit cleaner because I'm taking a little bit longer to wash the cars. That's cool. But I'm gonna skim through to the bottom. You can see here the cars are getting a little bit, on average. They're getting a little bit better. But I'm gonna skim all the way down to the end of the simulation at 58 minutes. So here's where things start to look a little different. So I'm starting to get backed up. and the simulation is showing that when I run this. So car 26 leaves the car wash at 56. Car 27 leaves the car wash, but then 28 enters the car wash at 56. But then look, car 39 arrives. That's very different from earlier. So that means that if I have 29, if car 29 enters the car wash at 56 minutes, that means that I've got a backlog of 9 cars. That means I've got 9 cars that are now backlogged. So after just in doubling the wash time, yeah, it gets my cars washed more. But now I've got a problem. I've got 10 customers that are sitting around that don't have a car, that they're just sitting around going, well, they're probably not going to sit around, right? So that means that 4 minutes probably is going to create unhappy customers. More than likely is going to create unhappy customers. So just to compare, if I go back to 2 minutes again, remember, see, we're right at the 59-minute mark. 35 leaves, 36 enters. That means there's no wait time in the queue. Whereas when we go back to 4 and then I rerun the simulation, I have 29 entering and 39 right. I mean, that's a problem. That means, again, I've got some wait. What if I go up to 6 minutes? What ends up happening? You would suspect that it's gonna get worse, right? And it does. We start to see the system really start to break down. So we actually are starting to see that we're getting all kinds of problems. When we increase the wash time, we now we've got 18 and 19 are entering our bay, and then car 36, which means 50% of my customers are now sitting and not getting a car washed, right? So, and that's increasing my wash time from 2 minutes to 6 minutes. And that's what's really cool about discrete event simulation. I'm making one adjustment to one parameter. I haven't even touched the car every 2 minutes. If I change this time interval and I said if I changed it to 5 minutes, that would probably alleviate some of my time crunch. Now, this is probably a car every 2 minutes is probably something that happens 2 times throughout the day. It's probably going to happen over lunch, and it's probably going to have to happen after work, right? Those are the time when you're going to get them. And you're probably going to be looking at time intervals of 10 minutes, 15 minutes when you're not off peak hours, right? So that's something to consider in your discrete event simulation. If you were going to build this out and make it a little bit more robust, those are different features you could add into the DES, the DE simulation, as it were. So I'm going to back this off to 2 minutes and go back to there. Okay, so what I'm going to do is I'm going to actually, that wraps up our lab for the follow along. And then I'm actually going to, that takes care of what we're talking about here. But what I want to do for the follow along is we're going to actually re-review, I'm sorry, not the follow along, for the U-try. We're going to actually, I'm going to pose some questions to you that I want you to goof around with. So I'm going to stop the recording, and that wraps up the follow along, and I will see you in the U-try lab.